Hello and welcome to the course on Research Software Engineering with Python at the University College London. In this first class and episode, I'll be introducing you to a version control system called Git. It's arguably one of the most popular version control systems there is to date, if not the most popular one. After a bit of background info and history, you'll be hearing from Sam Harrison. Sam is an environmental developer at the UK Centre for Ecology and Hydrology in Lancaster, and Git plays an important part in his daily work, as you will hear later. But let's start with some background and history of version control systems. How to manage and track different versions of your research material and research output is probably a question as old as research itself. And it affects everything from your draft of your thesis, background material, or a research paper, your experimental analysis, and nowadays, of course, the source code of the software you write. There are simply times when you need to go back to your previous version or work with others on the same documents and not override each other's changes. Over time, people have found different ways how to solve this. A very hand-wavy and pedestrian way is using a naming scheme. So, for instance, people have been adding version numbers or date and timestamps to file names, and I must confess I've done the same myself at some point. And it kind of works, at least initially. But after a while it starts getting messy and at some point downright unmanageable, in particular when you work with others. Software engineers have been thinking about this problem as well, and actually from quite early on. They came up with a number of solutions dating back to the 1960s when a team at IBM developed a software update management tool. In 1972, Mark Roshkind, also from IBM, introduced a system called Source Code Control System, or SCCS. A decade later, Walter Tichy from Purdue University in the US created the Revision Control System, RCS, which was followed by the Concurrent Version System, CVS. A few years and a number of acronyms later, in the year 2000, another version control system called Subversion was made available, which still exists and is now part of the Apache project. And of course, there are other version control systems as well, such as, for instance, Perforce. Some commercial vendors offered solutions as part of software development environments. So, for instance, Microsoft's Visual Studio had a system called Visual Studio SourceSave, which my colleagues and I used in the early 2000s to develop C++ code. So where is Git, you ask? Well, Git was released for the first time as late as 2005. And the creator of Git might be actually somebody you know, Linus Torvalds, or Linus as some people call him. You might recognize the name Linus Torvalds as the creator of the popular Linux operating systems, which he released in the early 1990s. Like with Linux, Linus made Git available as open source, and in the episode notes you will find the link to the Git repository itself, from where you can still download the first release version from the year 2005, should you so wish. And in the first release notes, Linus also tells us why Git is called Git, or rather he doesn't really, because what he really writes is, and I'm quoting, Git can mean anything, depending on your mood. And he continues saying, Git could be random 3-letter combination that is pronounceable and not usually used by any common Unix command. The fact that it is a mispronunciation of get may or may not be relevant. It could also mean stupid, contemptible, despicable, simple, take your pick from the dictionary of slang. It could also mean global information tracker. Well, he's got a sense of humor, has our Linus. And by the way, Linus wasn't the only one releasing a new version control system in 2005. In the same year, Olivia Mackel launched another version control system called Mercurial, and both Git and Mercurial are still in use today. But let's continue with Git. Since 2005, it has become popular very quickly, as it has been adopted in operating systems such as Linux and Mac OS, where it is actually pre-installed. What also helped the spread and the use of Git was the launch of a cloud-based source code management service called GitHub, only 3 years later in 2008. GitHub and Git work very well in tandem, and in the following episode, you'll find out more why. Nowadays, we have a bunch of cloud-based source control systems apart from GitHub, like for instance GitLab, which was created in 2011. As I mentioned, Git is pre-installed on Linux and Mac OS systems. It's of course also available for Windows, however, you'd need to download and install a version of it yourself. When it comes to Git version control system, there's quite a bit of lingo and terminology to get used to, and Sam Harrison and I talk about it in the interview shortly. But let's start with a few of those terms and discuss some of the very basic Git commands you'll be using quite often. First, there's the term repository, which is used by all version control systems, by the way. It is meant to be a storage for files and any changes you have made to them, that is, the version control history. Git itself is a so-called distributed version control system, which means that each developer or Git user has a local copy of the repository on their computer. There is no single or central repository. Being a distributed system has important consequences, and this takes me right to the first set of Git commands, the commands that allow you to get to an existing repository or to create a new one. So let's say you join a research team and they use Git to manage their source code and documents, and let's say that they also use GitHub as a joint cloud-based service. For you to get started, what you would need to do is to get a copy of the repository and all the files in it. It's a process that's called cloning. And therefore, in your command line terminal, you would use the following Git command: git clone, followed by the URL, that is the link to the team's repository on GitHub, or wherever it is. This will download everything in a Git repository, including the change in version history. Working with existing repositories is something you'll be doing quite often, and equally, you sometimes need to create a new repository from scratch, say right at the start of a new project. And the git command for that is simply git init. With both the git clone and the git init commands, you create repositories on your computer. And once you've done that, you're now ready to actually add new files and change existing ones, with Git taking care of all the changes. And this takes us to the last set of commands I want to talk about in this episode, which is how you can add new or changed files to your Git repository. This is a two-step process, and it's important to know how it works. Rather than putting new and changed files directly into your local Git repository, you will have to add them to a temporary holding space first, and this process is called staging. And the command for this is git add, followed by the files you want to add, or you can also simply do a git add dot for adding all changed and new files. Once you added them to the staging area, you can then move them into the repository for good, and this second command in the process is called git commit. The git commit command requires you to provide a text comment to describe the changes you've made, which kind of makes sense, and you can add that comment with a -m option in the git command directly. So in summary, the basic git commands we talked about today are git clone for getting an existing repository copied to your computer, git init for creating a new and empty repository. With git add, you move new and changed files into the Git staging area, and with git commit -m, you move files from the staging area into your repository with a comment attached to it. And in the class, you'll have the chance to practice all of these commands and some more with some other Git commands I haven't mentioned yet, such as how to configure Git on your machine. If you are new to version control systems, and Git in particular, I appreciate there's quite a bit to take in. Popular as it may be, it isn't always straightforward to get your head around it. And it's something I touched on in my conversation with Sam Harrison. So over to Sam now. Hello, Sam. Thanks very much for your time today. Let's start with brief introductions.
So my name's Sam Harrison. I work at the UK Centre for Ecology and Hydrology. I'm based up in Lancaster in the northwest of the UK. My main specialism is environmental exposure modelling. So I model the flows, the transports, chemistry of how different potential contaminants like microplastics, like pharmaceuticals, how they move around the environment and how that might affect environment and ecosystems. I've got a bit of a background in software type stuff, and obviously a large part of that modeling work now is building models, basically writing code, building models of environmental transport of contaminants.
And it's the software bit that we would like to talk about today, in particular version control systems. So from your perspective, how important are version control systems?
Yeah, I mean, they're pretty fundamental in what I do, the models that I write. I can't imagine being able to write the models, write the code, the scripts, etc., that I write without the use of version control systems, because it would be incredibly difficult to keep track of versions. It'd be very difficult to collaborate with colleagues. Yeah, they're very fundamental.
And you're using Git, I assume,
Yes,
for the
I
version
am.
control system. So have you ever used anything other than Git before?
Not in Angst, no. I've looked into other options before, but I think when I started my journey with version control, Git seemed to be the de facto tool to use. So I turned to that straight away and haven't looked back since.
So Git is usually used in conjunction with cloud services such as GitLab and GitHub and Bitbucket as well. These two are not the only ones. Which one are you using?
Predominantly GitHub. I've used others a little bit, but again, when I started with version control, GitHub seemed to be the go-to online repository. So that's what I'm most experienced with and what I most use.
So, from your point of view, what is it that makes Git so special? Is it special? And if so, why?
I think it is. I mean, generally taking version control systems, the point that what makes a version control system special is that ability to have different versions of your code, never lose old code. You know, if you imagine the world before version control systems, you might end up commenting out chunks of code because you don't want to necessarily lose them, but you don't want to use them anymore. So you end up with a messy script file with loads of comments everywhere. Version control systems, you can do away with that because that code is always going to be there on that version control
Mm,
system. It enables collaboration, much easier collaboration. You don't have to send files between people. You don't have to email files over. You don't have to be working on the same file, which can cause conflicts. It enables you to work with collaborators in parallel, merging those changes. And that really helps with things like reproducibility. So, for instance, if you run some scripts and produce some outputs and go and
mm,
publish those or write a report based on those, then it's useful knowing what version of the code was used to produce those outputs. And being able to tag versions, etc., in version control is a great way of being able to do that. In terms of Git over other version control systems, as I say, I haven't used others a huge amount, but I think a lot of the power of Git comes in how comprehensive it is. It can do a lot. That also makes it quite difficult to get started with and quite difficult to get a
yeah.
full grasp of. Yeah, that's a trade-off.
I would like to home in a little bit on the difficulties in working with Git. Nowadays, we have user interface based tools, such as, for instance, the one that comes for free with GitHub, which is GitHub Desktop. But a lot of the times, well, maybe not a lot of the times, but sometimes you may want to use the command line. So, how easy was it for you to get into Git, and how long do you think it took to actually get your head around
Yeah, I probably still haven't got my head around it fully.
it?
It's an ever learning process, I suppose, is the best way of looking at it, because as I say, it's very complex and powerful. I think it's not too difficult to get your head around the basics of adding files, committing files, pushing them up to remote repositories, pulling down changes. That's not too difficult. And it's a little bit confusing at first because there's lots of new terminology flying around,
Such
staging
as.
areas, or yeah, branches, staging areas, commits, tags, remote repositories. There's all these things that you kind of need to learn what they mean first. If you start out maybe by, looking at learning the basic setup of how Git works in terms of having a staging area and adding files to the staging area and then making commits. If you kind of learn that paradigm, those concepts, it helps a little bit and gets you going. And I think how most people learn it is just through practice, through experience. I
Mm.
suppose my tip in that area would be just try and practice with Git as much as you can. The more you use it, the more familiar you get with it, in the
Mhm.
knowledge that you will end up breaking things, but that's a learning experience.
Is that how you learned it? By just practicing it?
Absolutely, yeah. I mean, when I started, it was probably at the start of my PhD that I started using Git in Angst. And I used it not just for code. I decided, right, I'm going to invest in this. And so, for instance, I wrote my thesis using version control. So I wrote it in LaTeX, which is text-based files, and I used version control for that. Not necessarily because I needed to, although actually it
Yeah.
was quite useful, but it was a great way of just learning stuff on my own without having to worry about messing things up for collaborators.
That's quite an important message, actually, because it's not only used for source code, it can also be used for documents, for text-based documents, right? So I think for binary files, we need to be a little bit careful because I
Yes.
think it doesn't probably work that well. You can
Yeah.
store them in Git, but you can't do, for instance, things like comparing older versions with newer ones because they're in binary format. Can I just ask, how are you using Git? Is it through command line or do you use graphical user interface and application?
I use the command line. It's kind of what I'm most familiar with because I do quite a lot of coding, and I like using the command line for as much as I can, basically. I find that easier. I've tried using things like source tree before, but I think I've always reverted to the command line. But that's very much a personal preference. I just prefer typing commands and pressing enter. I know lots of colleagues that much prefer using the graphical versions because they find them more intuitive.
So you mentioned that you tried graphical versions like Source Tree. Are there any others that you heard of or you could recommend?
Yeah, I'm not so much of an expert here. GitHub, I think, has their own graphical desktop version, but to
Yeah.
be honest, I've never tried that. Source Tree, when I started, was one of the free options that seemed to be the most powerful, seemed to have a lot of features, and that's why I gave that a go.
Not quite sure how free it is these days when it comes to the graphical Git managing systems or the applications. Then there are the freebies like GitHub, and then there are other ones you can use but have to purchase or have to buy a subscription these days. In terms of learning to use Git on command line, what kind of tips would you give people? How do you memorize all these different commands? Because there are quite a few on there.
Yeah, it kind of goes back to the practice point a little bit. You use it for as much as you can because I think that's the best way of kind of committing stuff to memory. I mean, there's a few things you could. So, for instance, cheat sheets are quite good resources, and if you
Mhm.
Google Git cheat sheet, you'll get tons of results of like people have just compiled like a little cheat sheet of these are the common commands, and you can have that as a reference. You know, you could print it out, put it on your desk, and that's a way of quickly being able to learn the commands. I think actually what I started doing, and I found this more useful, is I made my own cheat sheet. So as I was
Mm.
going along, if I learned a new command, then I'd add it to the cheat sheet. I don't know, the way my brain works is that I'm much more likely to remember something if I write it down.
So, what are the basic commands in Git that you're using and that you would recommend people to start with out of that whole pool of different commands?
Yeah, I think the key things are adding, so git add, and then with a dot after that, that basically adds all of your files that you're currently working on to what they call a staging area. Git commit -m and then inverted quote marks a message. So that commits those files that you've just staged and then gives it a message saying what the commit message is. So you've got git add, git commit, and then if you have a remote repository set up, you can then push those files to that remote repository. So git push, and then the name of the remote repository, which is often origin, and then the
Mm.
name of the branch you're pushing to. And by the way, this is why I say it starts getting complex because even the simple commands,
Yeah.
you start delving into what remotes are, what branches are. But the common one there would be git push origin main or git push origin master potentially, depending on what your branch names are. And then if you're working with collaborators, then the opposite of that, so getting code off the remote repository, is git pull, again, origin main,
Mm.
origin master. For instance, if I was collaborating on a repository, what I would generally do, my workflow would be to go to that code. If I'm starting new, git pull. So I get code from any of my collaborators that have written
Mhm.
code whilst I've been away. And then I do my edits, then I'll git add, git commit, and git push. The other important ones are git clone and then a URL, and that pulls code from a remote repository that you don't already have. And git init creates a new blank repository. They're probably the key ones.
Got quite a few. Git init, which is probably where you start with a brand new Git repository, then git add files to the staging area, commit, which is where you commit it locally to
Yes.
the database, because that's what Git maintains. And then you have the interaction with a remote repository. So it's quite a bit to get your head around. I quite like the idea of creating your own cheat sheet. Are you still adding to the cheat sheet?
I'm not actually anymore. That's a good question. I probably should, because I find myself Googling problems that I've encountered lots of times before and can't remember how to solve them. So maybe this should be a prompt to me to go back to that cheat sheet and carry on updating it.
Well, I think that using a cheat sheet yourself and creating one is a jolly good idea, and maybe you start one right now when you start with Git. But Sam mentioned a number of commands I haven't touched on yet, and in particular how Git interacts with cloud-based services such as GitHub or GitLab, which I already mentioned a little bit earlier. And all of this and more will be for the next episode, where you will hear from Sam again and from Irini Solber from the Alan Turing Institute. You will find the material for this course on the Moodle platform at UCL. This podcast is produced by Peter Schmidt. The music comes from Daniel Lindenblatt in Berlin, Germany. And finally, thank you for listening, and I hope you enjoy the course. And with that, goodbye.